electric field, you see, electric field intensity at any point due to a short electric dipole. So question, this will be question, explain or derive the expression for electric field intensity at any point due to a short electric dipole. And the last two cases we have seen, one the point when the point is along the axial line and when the point is along the equatorial line, we have derived the expression for the electric field intensity. But here K, you have considered a point K which is not along the axial line nor along the equatorial line, any other direction, you see. K, this is K, this is not equatorial. Equatorial means perpendicular bisector. No, it is not on that line. Axial means along this line. No, K is not along the axial line, but it is along, it is inclined at an angle theta. So when you draw a line from the center of the dipole, here AB is the dipole, red one. AB is the dipole, minus Q plus Q, separated by a distance 2A. Center, O is the center of the dipole. First you have to explain figure. AB is the dipole. Dipole momentum vector P. Direction of dipole moment minus Q to plus Q. O is the center point. Where is K lying? K is at a distance R from O, which is making an angle theta. See, this angle is theta. You have to mark theta, inclined at an angle. It is not 0, it is not 90, it is any other angle other than 0 or 90, other than that, any other angle, theta. So here, how will you find the electric field density at K? For that, first you have to take the components of vector P. Vector P direction is marked here, OB. See, in your figure, I haven't represented these components. Please write now. If you have a notebook now, you please write this, P cos theta here and P sin theta here. Please write in your notebook. Is notebook with you, children?
Yes, ma'am.
Then you write P cos theta here. See, near to the theta, we get P cos theta. Near to or perpendicular to that, we get P sin theta. So you mark the components of P. All of you mark? Then, under that situation, where is K line? K is, see, this is P cos theta component. So it is along the axial line of that P cos theta. Here A1, B1, we can draw A1, B1, and there the component of P cos theta is lying. So now K is along the axial line. See, now in order to make the derivation easy, we are considering this method. Clear? So what we have to consider? First we have to split the vector into two components. Near to the theta, P cos theta. Perpendicular to that, P sin theta. We got two components. Then where is K line with respect to A1, B1? A1, B1 position. A1, B1 position with respect to A1, B1. Where is K line? Where is K line? I will ask to Maharunisa. Where is K line with respect to A1, B1? Maharunisa?
Yes, teacher.
With respect to A1, B1, where is K line?
A1, B1. Along the
axial line. And this axis ആണ്. Axial line with respect to A1, B1, it is along the axial line. With respect to A2, B2, Lakshmi Priya tell, with respect to A2, B2, where is K line? Equatorial line. See, along the perpendicular. So A2, B2 is perpendicular line. This is a perpendicular line. This is the equatorial line of A2, B2. So K is lying on the equatorial line of A2, B2. Okay. Now, see, we are representing along the axial line. When it lies along the axial line of A1, B1, it makes an electric field intensity E1. What is its magnitude? Its magnitude, you can tell. You see, along the, we are considering short dipole. Short dipole. In that case, axial line 1 by 4 pi epsilon 0 2p by r cube. That equation we can write. 2p by r cube. That equation we are taking. Okay. Along the equatorial for a short dipole Krishna Prabha, what is the equation? Here instead of p, you have to tell p cos p sin theta. P sin theta parayana. A2 B2 in the position.
Yes, teacher.
What is E2? 1 by 4 pi epsilon 0.
1 by 4 pi epsilon 0 into p sin theta by r cube.
P sin theta by r cube. And its direction is, here can you tell which direction in this figure? E2 in the direction, bara. Direction of E2. K? Km, correct. Km ആണ്. Perpendicular, കണ്ട. A2, B2, അതിന് perpendicular ആയിട്ട്, കണ്ട. Equatorial line, dipole moment in the direction opposite ആയിരിക്കും direction. But they will be parallel. രണ്ട് parallel ആണ്. Okay. E1 and E2 we got acting at the point K, two vectors. E1 and E2 are two vectors. And here we have to take the resultant. How will you find the resultant? We use parallelogram law of vector addition. Complete the parallelogram and draw the diagonal. This diagonal will give E. So that also you have to write here. Vector E right here. Resultant field vector E. K n. Kn gives the resultant field. All of you write in your notebook. This is vector E. Vector E that's the resultant field. Okay. Along Kn. Resultant field is along Kn. Now we have to find resultant. Resultant, how will you find? Parallelogram law equation tell. Who will tell? Adilashmi, what is the equation for parallelogram law of vector addition? If vector P and vector Q are making an angle theta, what is the equation for resultant electric field? നമ്മൾ കഴിഞ്ഞെല്ലാം പഠിച്ചല്ലേ parallelogram law of vector addition. Adilakshmi, resultant R equal to root of. Can you complete, Adilakshmi? Yes or no? Don't waste time. No? Network not getting. No, it's not clear. Akshaya, you tell what is the equation? Akshaya.
Teacher.
Don't know?
I don't know.
Okay, no problem. If you yes or no, you can tell. No problem. Anyone? Can you tell anyone? Anyone?
Root of x square plus b square into ab cos theta.
2ab cos theta. Square root of x square plus b square plus 2ab cos theta. Theta is the angle between the two vectors. Tell. Who is calling? Okay. Last year we have studied R equal to root of p square plus q square plus 2pq cos theta. That is the resultant. And here theta is the angle between E2 and E1. In this case, what is the angle between E2 and E1? Aparna, what is the angle between E2 and E1? Aparna, yes or no, please tell. Gautam, what is the angle between E2 and E1? Gautam? 90 degree. So equation becomes square root of E1 square plus E2 square plus 2 E1 E2 cos 90. What is cos 90, Gautam? 2 E1 E2 cos 90. Cos 90, Gautam, what is cos 90? Why taking too much time for cos 90? You don't know?
Yes, ma'am.
What is the angle? What is cos 90? Cos 90. Cos 90
0.
value 0. Okay. Well, third term becomes 0. 2 E1 E2 cos 90. That becomes 0. So what remains? Root of E1 square plus E2 square. E is equal to modulus of vector E is equal to square root of E1 square plus E2 square. Third term is not there. because it is cos 90. Angle between E2 and E1 is 90 degree. 2 E1, E2 cos 90 term, that becomes 0. So only which terms are there? Root of E1 square plus E2 square. Only those two terms are there. Okay. So let us substitute the values. E1 is equal to, 1 by 4 pi epsilon 0, 2 p cos theta by r cube for a short dipole. And equatorial line, we know 1 by 4 pi epsilon 0, p sin theta by r cube. And that also we know. Therefore, vector modulus of vector E, resultant field is equal to root of E1 square plus E2 square. Then we are squaring it and adding it. Just square it. Then common factors are taken outside. See, 1 by 4 pi epsilon 0 r cube. Both the terms it is there. Actually, inside there is square. So when it is taken outside the root, it becomes p by 4 pi epsilon 0 r cube. That is outside the square root. Then inside the root, you see 2 cos theta whole square. What is it? 2 cos theta whole square, 4 cos square theta. Plus sin theta whole square. What's it? Sin square theta. Sin square theta we got. Next step, see, cos square theta plus sin square theta is 1. So 3 cos square theta plus 1 cos square theta is added with this sin square theta. So we get 3 cos square theta plus 1. ഏതെങ്കിലും സ്റ്റെപ്പ് മനസ്സിലാവണില്ലെങ്കിൽ ടീച്ചറോട് പറയണം. നല്ല കുട്ടികളായിട്ട് അല്ലാതെ മിണ്ടാതെ ഇരുന്നിട്ട് എനിക്ക് മനസ്സിലാവണില്ല എന്ന് ഒറ്റ ആൾ പറയാൻ പാടില്ല. ഒറ്റ ആൾ പറയാൻ പാടില്ല. That is what I told you. You split this into 2 parts. 3 cos square theta plus cos square theta, like that. First, okay? 3 cos square theta plus cos square theta. Then that plus cos square theta is added with this. So what it becomes, Marnisa?
1.
1. So that is written here. Clear?
Yes, ma'am.
Okay, very good. Like that, you have to ask doubt in between. If any doubt, any step, if you didn't understand, please call me or please tell me. I will explain. Nobody should tell, I didn't understand, physics is difficult. Why it is difficult? You are not taking any effort to study that. That's why. If you understand all the derivations and why it is difficult. You are not studying. That's why. So each and every step I am ready to explain why this happens. The only duty is yours. You have to prepare well. Every day's portion study well. Okay. In the final expression we got p by 4 pi epsilon 0 r cube into root of 3 cos square theta plus 1. So everybody should write the derivation 2 times and final expression by heart it. No doubt should be there in the final expression. So let angle LKN equal to infinity. And direction, in order to find the direction, I will show you the figure. See this figure, magnitude we got root of E1 square plus E2 square. By that method we got the magnitude of resultant electric field Kn. Next we have to find out alpha. This is the direction. What is the direction of the resultant? With respect to this E1, what is its direction? For that, what we find tan alpha. Tan alpha gives the direction. Tan alpha means opposite side by Ln by adjacent side. What is Ln? Ln is E2. Ln is E2. So E2 by E1 will give alpha. So we can divide E2 by E1, we can find out. E2 by E1 we can find out. Yes. Special case. Again, not moving. Tan alpha. Tan alpha gives the direction. So this is magnitude and final tan alpha. Tan alpha is E2 by E1. So you just multiplied it. as it is divided, you have to multiply, inverting it, invert it and multiply, and we get tan alpha equal to half tan theta. Other things cancel. Sin theta by cos theta, tan theta, and 1 by 2 is there. All other factors cancel, and we get tan alpha equal to half tan theta. And like that, we can calculate direction alpha. If the angle between the two vectors, if you know, you can calculate theta അറിഞ്ഞു കഴിഞ്ഞാൽ ഡയറക്ഷൻ എന്താണെന്ന് കണ്ടുപിടിക്കുക. ഈ ഫോർമുലയിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. എനി ഡൗട്ട്?
കഴിഞ്ഞിട്ട് എന്താ എഴുതിയിരിക്കുന്നത്?
ഏത് കഴിഞ്ഞിട്ട്?
ടാൻ ആൽഫ ഡയറക്ഷൻ കഴിഞ്ഞിട്ട് ഒരു ഓർ ഇട്ടിട്ട് എന്ത് എഴുതിയില്ലേ? ടാൻ സംതിങ്.
അതിവിടെ ടാൻ ആൽഫ ഈക്വൽ ടു എഴുതാൻ പോയതായിരുന്നു ഇവിടെ. അപ്പൊ ഇവിടെ സ്ഥലമില്ല. ടാൻ ആൽഫ ഈക്വൽ ടു അത് വെട്ടിക്കളഞ്ഞോളൂ കേട്ടോ. ടാൻ ആൽഫ ഈക്വൽ ടു ഹാഫ് ടാൻ തീറ്റ. ഓക്കെ, പറഞ്ഞു, വേഗം പറഞ്ഞു, സംശയമൊക്കെ പറയണം. വേണം വേണം, ഡെറിവേഷൻ ചോദിച്ചാലും മാഗ്നിറ്റ്യൂഡും ഡയറക്ഷനും കാണണം കേട്ടോ. മാഗ്നിറ്റ്യൂഡിന് 1/2 മാർക്ക് ഡയറക്ഷനാണ്. അപ്പോൾ 1/2 മാർക്ക് പോവില്ലേ നമ്മുടെ. മാഗ്നിറ്റ്യൂഡ് വെക്ടർ ക്വാണ്ടിറ്റി ആയതുകൊണ്ട് മാഗ്നിറ്റ്യൂഡും ഡയറക്ഷനും പറയണം. ഓക്കെ, അപ്പോൾ ഈ ഡെറിവേഷൻ എഴുതിയിട്ട് മാഗ്നിറ്റ്യൂഡ് യു ഹാവ് ടു റൈറ്റ് ആൻഡ് ഫൈൻഡ് ദ ഡയറക്ഷൻ. ടെൽ മീ.
ഫീൽഡ് അറ്റ് പോയിന്റ് ഇനിയർ പോയിന്റും നോർമൽ ഡൈപോളിന് ചോദിക്കോ?
അറ്റ് എനി പോയിന്റ് ചിലപ്പോൾ സ്പെഷ്യൽ കേസ് ആയിട്ട് ചോദിക്കും. അതായത് അലോങ് ദി ഇക്വറ്റോറിയൽ ലൈൻ, അലോങ് ദി എക്സൽ ലൈൻ, അതാണ് സ്പെഷ്യൽ കേസ് ആയിട്ട് ചോദിക്കുന്നത് കേട്ടോ. നോർമൽ
ഇനി പോയിന്റ് അല്ല, അപ്പൊ അതുപോലെ തന്നെ ഇനി ഇപ്പൊ എക്സിയലിലും ഇക്വറ്റോറിയൽ അല്ലാണ്ട് ഒരു പോയിന്റ് വന്നിട്ട് ചോദിക്കോ നോർമൽ ഡൈപോളിന്?
അതാണിത് അറ്റ് എനി പോയിന്റ് അല്ലേ ഇത്. പിന്നെ അല്ല, അത് വേറെ കേസില്ലല്ലോ. നോർമലി ഇക്വറ്റോറിയൽ അറ്റ് എനി പോയിന്റ് ഏത് ആംഗിള് അറിഞ്ഞാൽ മതി, 2 വെക്ടറിൻ്റെ കേട്ടോ. ഓക്കെ, ഇനി നമ്മൾ നേരത്തെ ഡിറൈവ് ചെയ്ത സ്പെഷ്യൽ കേസസ് എങ്ങനെയാണ് ഇതിൽ നിന്ന് കിട്ടാൻ നോക്കാം. ഫ്രം ദിസ് എക്സ്പ്രഷൻ, ഹൗ വിൽ യു ഫൈൻഡ് ദി ഇലക്ട്രിക് ഫീൽഡ് അലോങ് ദി എക്സൽ ലൈൻ ആൻഡ് ദി ഇക്വറ്റോറിയൽ ലൈൻ? When point K lies on the axial line of dipole, theta becomes 0. ഫിഗറിൽ കാണിച്ചു തരാം. ഫിഗറിൽ when point K lies along the axial line, ഇവിടെ ഇത് ഈ ലൈൻ എക്സ്റ്റെൻഡ് ചെയ്തിട്ട് ഇവിടെയാണെന്ന് വിചാരിക്കുക. അപ്പോൾ തീറ്റ എന്തായിരിക്കും? ദേവിക, വാട്ട് ഈസ് തീറ്റ when K is here? കഴ്സർ വെച്ചിട്ടില്ലേ, ഇവിടെയാണെങ്കിൽ ആക്സിയൽ ലൈൻ. when K is here, what is theta? ദേവിക?
Yes, ma'am.
When K is here, where the cursor is kept, that is along the axial line. What is theta? What is theta?
Cos theta.
Theta becomes what when it is along the axial line? When it is here, it is theta. When it is along the axial line, K is along the axial line, what is theta? Value. Aisha, what is theta? അറിയോ?
90 degree.
ഇവിടെ ഈ ലൈന് വെച്ചാൽ എങ്ങനെയാണ് 90 ആവുന്നത്? എത്രയാണ്? 0 ഡിഗ്രി അല്ലേ ഈ ലൈനുമ്മ കണ്ടാ. ഇത് ഇങ്ങോട്ട് താഴ്ത്തിക്കോന്ന് 0 ആവും കണ്ടാ. ഇത് ഇങ്ങോട്ട് പോവുകയാണെങ്കിൽ അത് ഇപ്പൊ ഇവിടെയാണ് വേണ്ട പെർപെൻഡിക്കുലർ, ഇവിടെയാണ് K എന്നെങ്കിൽ നമുക്ക് 90 എന്ന് പറയാം. K ഇവിടെ ആണെങ്കിലാണ് 90 ആവുള്ളൂ കണ്ടാ. ഇപ്പം ഇവിടെ ആകുമ്പോൾ അത് 0 ആണ് ആവുക കേട്ടോ. ആക്സിയൽ ലൈനിലാകുമ്പോൾ 0 ആണ്. ദേവിക, അണ്ടർസ്റ്റുഡ്?
Yes, ma'am. Yes, ma'am.
Okay. But we are discussing special case. When theta is 0 along the axis, when K lies along the axial line of dipole, theta 0, cos theta, cos 0, that becomes 1. So substituting in the equation for the electric field intensity, modulus of vector E equal to P by 4 pi epsilon 0 r cube into 3 cos square theta plus 1. Cos theta becomes cos 0, that equal to 1. അപ്പോൾ 3 plus 1 ആയി. 3 plus 1 എത്ര? 4. 4ൻ്റെ റൂട്ട് എത്രയാ? 2. അപ്പോൾ 2p എന്നായി കണ്ട. അപ്പം നമുക്ക് നേരത്തെ കിട്ടിയ എക്സ്പ്രഷൻ കിട്ടില്ലേ? ഫോർ എ ഷോർട്ട് ഡൈപോൾ, വാട്ട് ഈസ് ദ ഇലക്ട്രിക് ഫീൽഡ് ഇന്റൻസിറ്റി? 2p by 4 pi epsilon 0 r cube. And its direction tan alpha equal to half tan 0. Tan 0 we know 0. So we get tan alpha 0 എന്ന് കിട്ടി. Tan alpha 0. അപ്പോൾ alpha also 0 എന്ന് കിട്ടി. Along the XL line ആവുമ്പോൾ കേട്ടോ. Resultant intensity is along the XL line. Similarly, equatorial line. When K lies on the equatorial line, theta becomes 90. Cos theta becomes cos 90 equal to 0. So in this expression, P by 4 pi epsilon 0 r cube into root of 3 cos square 90 plus 1. Cos 90 0, so this will not be there. This term 0 plus 1, root 1, above 1 then. P by 4 pi epsilon 0 r cube. This is the expression we got for the electric field intensity when point is along the equatorial line of a short dipole. We got this expression. Similarly, direction half tan 90. Theta is 90, so we have to write half tan 90. Tan 90 is infinity, so we get tan alpha becomes infinity. That means alpha equal to 90 degree. Alpha equal to 90 degree. So it will be along the equatorial line. The direction of resultant field intensity is perpendicular to the equatorial line and hence anti-parallel to axial line. Is it clear, this factor? Children?
Ma'am.
Doubt undo?
അത് മാം ആ ഫിഗറിൽ ഡൗട്ട് ഉണ്ട്.
ഫിഗറിൽ ഓക്കെ. ഇതിലാ
അത് മാം അപ്പോ മിഡിന്നല്ല ലൈന് വരച്ചിരിക്കുന്നത് കെന്റെ അവിടെ നിന്ന്.
ഇതാ
ഐ മീൻ A1 B1 A2 B2. പക്ഷെ മാം ക്യൂ പ്ലസ് ക്യൂ മൈനസ് ക്യൂ കെനൊരു എഫക്ട് കൊടുക്കണില്ലേ? കെനൊരു പ്ലസ് ക്യൂ
അതിന്റെ കമ്പോണന്റ് ആണ് ഇതിൽ ആക്ട് ചെയ്യുന്നത്. ഈ വെക്ടറിന്റെ കമ്പോണന്റ് വെക്ടർ മാത്രമേ ഇതിലേ കൂടെ ആക്ട് ചെയ്യുന്നുള്ളൂ കേട്ടാ. അതുകൊണ്ടാണ് അപ്പൊ അതിന് ഉണ്ട് കോസ് തീറ്റ എന്നുള്ള കമ്പോണന്റ് ഉണ്ടല്ലോ, അതുകൊണ്ടാണ് അത് വെച്ചത് കേട്ടാ. അപ്പൊ ഇതാണ് ഞാൻ പറഞ്ഞത് KM E2 കണ്ടാ. E2 ഈസ് പെർപെൻഡിക്കുലർ ടു കണ്ടാ ദിസ് പൊസിഷൻ. അല്ല, ഇക്വറ്റോറിയൽ ലൈനിന് പെർപെൻഡിക്കുലർ. ഇറ്റ് ഈസ് പെർപെൻഡിക്കുലർ ടു ദി ഇക്വറ്റോറിയൽ ലൈൻ ബട്ട് പാരലൽ ടു anti-parallel to dipole moment. Dipole moment is A2 B2 direction, but it is in the direction B2 A2. കണ്ടാ. അപ്പൊ ഹിയർ KM is, I will express it. It is perpendicular to the equatorial line but anti-parallel to A2 B2. That is what is written there. Field along the equatorial line, perpendicular to the equatorial line, anti-parallel to the dipole moment. അതായത് A2 B2. അപ്പം അതാണ് നമ്മൾ ഡിസ്കസ് ചെയ്ത് കഴിഞ്ഞത് കേട്ടോ. All of you have to write the derivation 2 times and keep it there. Whenever I ask, you have to show it to me. Okay. One class I will keep for that, for checking your books in Google Meet. Google Meet we will get 1 hour, so we can check that. Okay. So next is a very, very, very important portion. That is electric dipole in a 2-dimensional electric field. For that I will show you a video, so it will be more interesting. That's why I will show a video. What is the, see, heading you see, electric dipole in a uniform 2-dimensional electric field. When a dipole is kept in a uniform 2-dimensional electric field, what will happen to it? What is its behavior when it is kept in a uniform electric field? That's what we have to find out. Okay, I will show you the video, children. Why it is blank? Just wait for some more time. Taking time. Okay. NLP system activated.
Very greater than a
Okay.
if equatorial is kp by x cube. So if you compare the
NLP. Oh, bad.
now when is the torque maximum? When the value of sine theta is maximum.
Big.
So what happens here, this force will try to push it in this direction, this force will try to push it in this direction, and as a result this entire dipole or this entire rod will start rotating. So and that is what is called as torque. So here net force is equal to 0, but net torque is non-zero. So how much is the torque experienced by this dipole? Torque is given by P cross E, where P is the dipole moment and E is this electric field. So P cross E is basically PE sine theta, where theta is the angle that it makes with the electric field. Now, when is the torque maximum?
Okay, I will explain. So here you can see a uniform electric field. How can you produce an electric field, children? How can you produce an electric field?
Keeping a test charge.
By keeping a charge. Okay, measuring that you bring a test charge. Okay, if your charge is kept here, you just keep a charge. Around that there is an electric field. Okay, so any charge, positive charge, negative charge, any charge you can keep. But how will you create a uniform electric field? For example, a charge. For example, you can keep a charged wire. Charged wire, positively charged. So I have one figure I have already given to you. From that parallel lines, electric lines of force are passing. So actually uniform field is represented by equidistant parallel lines. All are equidistant, same distance between the two lines. Equidistant parallel lines represent a uniform electric field. And a capacitor that you are going to study only. In a capacitor, there is a uniform field. Okay, one plate is positive, other plate is negative. Then you can see a uniform field between that. So here, first what you have to draw? Dipole in uniform electric field. That is what we are studying. Dipole in uniform electric field. So first you have to draw uniform electric field. So how will you draw uniform electric field? Equispaced parallel lines. That is the representation of uniform electric field. Then what to do next? Dipole. Dipole is kept in that. What's a dipole? Two equal and opposite charges separated by a distance. Q minus Q plus Q, they are separated by a distance 2a. 2a is the distance of separation. And here, both the charges, when a charge is kept in an electric field, we know it experiences a force F equal to QE. That is what we have studied. E equal to F by Q. E equal to F by Q. So F equal to Q into E. So each charge will experience a force F equal to QE. See, children, I am going to ask question. So this is a single system. Dipole, that's a system. It is not separated. There is a separation between the charges, but it is a single system. Understand? In that, minus Q will experience a force, plus Q also will experience a force. Plus Q will experience a force F equal to QE. Which direction positive charge move, children? Which direction? In the direction of field or opposite direction of field?
In the direction of
In
field.
the direction, correct. Positive charge, the direction in which unit positive charge move, that is the direction of electric field. So positive charge will move, experience a force in the direction of electric field. Not moving, it will experience a force. The positive charge experience a force in the direction of electric field. So negative charge will experience a force. Tell me, which direction?
Opposite to the electric field.
Opposite to the direction of electric field. So plus Q, we have to represent this red line. F equal to QE in the direction of the field. Arrow mark under, it is towards the right. So just like that, we have to represent the direction F equal to vector QE, vector F equal to Q into vector E. So force direction is in the direction of the field. And here, red line is marked here, opposite to the direction of the field. Then next question comes, children. Now we know the force acting on plus Q charge, plus QE in the direction of the field, and force acting on the minus Q charge opposite to the direction of the electric field. What is the net force acting on the system? What is the net force acting on the system? Net force. Eh?
The difference.
What is the difference? One force is F plus QE and other is minus QE. That means minus represent opposite direction. Zero. That is the correct answer. Net force acting on the system is zero because they are opposite. Magnitudes are equal. Direction is opposite. So net force acting on the system is zero. So it will not experience any translatory motion. There is no translatory motion. Because net force, we know, we have already studied last year. If force is net force is acting on zero, then it will not have any translatory movement here. Understand? So here the net force acting on it is zero. No translatory motion is acting, but you know it will experience a rotatory motion. How? That we have to see. So that also we have studied last year. Two unlike parallel forces acting on a system constitute a couple. That also we have studied. Two unlike means opposite. Two unlike parallel forces. These two are parallel. Two unlike parallel forces acting on the system constitute a couple. So that means it will have a rotating effect. That we tell the torque is acting, rotating motion, that is torque. Torque is the rotating effect of the force. Due to this force, it experiences a torque. So how will you find out the torque? Either force into perpendicular distance. That is torque. Either force into perpendicular distance. Those things we have studied last year. Torque is equal to force into perpendicular distance. So then I will show our page.
When the value of sine theta is maximum.
Okay, it's in this derivation is not there. Okay. Our page, we can go back to our page. So when a dipole is kept in a, here I have drawn the field upwards, red line, electric field, and dipole is minus Q plus Q, green colored one. Dipole moment direction minus Q to plus Q, vector P, and then that's the figure. Minus Q to plus Q, vector P direction, and the dipole is making an angle theta with the direction of the field line. Theta with the direction of the field line. Dipole is making an angle theta with the direction of the field line. And here, net force acting, force F, the plus Q will experience a force in the direction of the field, plus QE. Minus Q will experience a force opposite to the direction of the electric field, minus QE. Net force acting on the system is zero, but it experiences a torque, rotating effect. And rotating effect, which direction it will rotate, children? Here, A is experiencing a force downwards and B is experiencing a force upwards. The system, you just keep your pen in that manner and apply force. Keep a pen in front of you and one force upwards, other force downwards. Act, you just exert force like that, in that manner. Anti-clockwise or clockwise, it will move, children. Just tell.
Anti-clockwise.
See?
Anti-clockwise.
Clockwise. ശ്രദ്ധിച്ചിട്ട് പറ. രണ്ട് it is
Anti-clockwise.
one is upward. അതായത് റൈറ്റ് സൈഡിലുള്ളത് അപ്വേർഡ്സ്, ലെഫ്റ്റ് സൈഡിലുള്ളത് ഡൗൺവേർഡ്സ്. എങ്ങടാണ് മൂവ്മെന്റ് ഉണ്ടാവുക, റൊട്ടേഷൻ ഉണ്ടാവുക എങ്ങടാണ്? പ്ലീസ് ടെൽ.
Anti-clockwise.
എല്ലാരും പറ. All of you take a pen and apply force in that manner. Anti-clockwise or clockwise? Tell me.
Anti-clockwise.
Anti-clockwise. Anti-clockwise direction it will rotate. Understood? So it will experience a torque in the anti-clockwise direction, and its magnitude is force into perpendicular distance. What is force? QE. What is the perpendicular distance? Perpendicular distance between the two forces is AC, represented by AC. How will you find AC? Sin theta. You have to find out sin theta. What is sin theta? Opposite side by hypotenuse. Hypotenuse is 2a. 2a is the distance between the two charges. So this is the perpendicular distance. AC by 2a sin theta. So AC equal to 2a sin theta. AC equal to 2a sin theta. 2a sin theta. We got q into 2a into e sin theta. F equal to QE. Torque is equal to PE sin theta. P cross E ആണ്. Force into perpendicular distance AC. F into AB sin theta. F into 2A sin theta. F equal to QE. QE into 2A sin theta. What is Q into 2A, children? Q into 2A. Either charge into distance P. So we can write PE sin theta. Torque is equal to PE sin theta. What is P, children? What is P?
Dipole moment.
Dipole moment. So PE sin theta can be written as P cross E because both are vectors. So in vector form, how will you write? Vector tau is equal to vector P cross E. So in vector form, this is the magnitude, and direction of torque will be perpendicular to both P and E. It is given last year we have studied. The direction is given by right-handed screw rule. Perpendicular to both these vectors. Vector tau is perpendicular to both the vectors. Understand? And special cases, when is the torque maximum? When theta is 90. Angle between P and E 90.